For you today will explain rules in mathematics, geometric, second term. First, we'll talk about the polygon. We know polygon shapes consist of 3 sides or more, such that triangle has 3 sides and quadrilateral has 4 sides. Sum of angles in triangle, sum of angle in triangle equal 180 degree, and quadrilateral sum of interior angles is 360. And the number of sides of pentagon has 5 sides, hexagon has 6 sides, heptagon 7 sides, octagon 8 sides, nonagon 9 sides, decagon 10 sides. Okay, penta, hexa, hepta, octa, non, deca. You must write GON at the end of this word. Penta, hexa, hepta, octa, non, deca. Okay, and what about exterior angle and interior angle? Exterior here, such as that in this triangle we call this angle exterior, and here angles we called it interior angles. Okay, regular polygon, all sides are equal and all angles are equal, such that equilateral triangle we called it regular polygon, has 3 sides quality and 3 angles equal in measure. Okay, what about regular polygon again? Regular polygon, all sides are equal and all angles equal in measure, such that square has 4 sides equal lengths and 4 angles equal in the measure. Sum of interior angles of inside n subtract by 2 product by 180. To find sum of interior angle in a quadrilateral, we can write n subtract by 2 in brackets product by 180. In here, reverse to the number of sides. If we have 3 sides, put it in equal 3, such that triangle has 3 sides. To find sum of interior angle, put in equal 3. 3 minus 2 equal 1. 1 times 180 equal 180. And what about parallelogram? Sum of interior angles here equal 360. If you put in equal 4, then 4 minus 2 equal 2. 2 times 180 equal 360. Then the sum of interior angle in this parallelogram equal 360. Sum of exterior angle of a polygon is 360. The sum of exterior angles of a polygon is 360. Okay, in a polygon, to find sum of exterior angles, it will be 360. You must put in your mind this number. And the measure of interior angle of regular polygon is n subtract by 2 product by 180 over n, such that equilateral triangle. If you want to find the measure of each angles of this equilateral triangle, you must put in equal 3, because we have regular triangle, we call this equilateral triangle. Put in equal 3. 3 subtract by 2 product by 180 over 3, then the result will be 60 degrees. The measure of each angles here equal 300. The measure of each angles here equal 3 minus 2 product by 180 over 3. It will be 60 degree. Okay, and sum of interior angles in equilateral equal 360, and sum of exterior angles of a polygon is 360. To find the number of sides, you must write 360 over 180 subtract by x. We use this rule to find the number of sides about regular polygon, such as that square. Okay, if we have angle here was 90 in the square, you can write the number of sides. The number of sides of regular polygon, it will be 360 over 180 subtracted by x. X here reverse to the measure of each angles in this regular, such that square. Each angle here equality, the measure of each angle equal 90 degree. Then you can put x here equal 90 degree, and then 360 divided by 2 here, 360 divided by 180 subtract by 90, it will be 360 divided by 90, it will be 4 sides. Then to find the number of sides of regular polygon, you must use this rule, 360 over 180 subtract by x, such that x is the measure of interior angle. And the number of diagonal, to find the number of diagonal, you must put the rule, number of diagonal. What about the diagonal? The diagonal is line segment joined between opposite angles. We call this diagonal. To find the number of diagonal in any quadral you can write, or any polygon you can write this rule, n subtract by 3 product by n over 2, n product by n minus 3 over 2. n here refers to the number of sides. Look at the pentagon. Look at the pentagon. We have 1 2 3 4 5. This pentagon, the number of sides equals the number of diagonal in the pentagon. It's a special case. Okay, we have 1 2 3 4 5. It's how many diagonals here? We have 1 2 3 4 5. Okay, 5 diagonals. Draw it again here. If we have pentagon, this shape, we can draw 1 2 3 4 5. Okay, 1 2 3 4 5. 5 diagonal, and the number of sides of pentagon was 5. Then the special case, the number of sides in pentagon equals the number of diagonals, and we know the diagonal is the line segment joined between opposite angles. It's diagonal. Okay, we call this diagonal. This part, this line segment, diagonal. Number of axes of symmetry of isosceles triangle. The isosceles triangle has only one line symmetry. What about isosceles trapezium? Isosceles trapezium has only one line symmetry. And square has 4 line symmetry. 1 2 3 4. Okay, 4 line symmetry of square. Rectangle has 2 line symmetry. Rhombus, all sides equal lenses rhombus. A rhombus has 2 diagonals. The 2 diagonals here will be 2 line symmetry. Then in rhombus we have 2 line symmetry. Parallelogram, we haven't any line symmetry in parallelogram, 0. Then the number of line symmetry of parallelogram, it will be 0. Scalene triangle, such that this triangle we call the scalene. We have different sides here, then we have 0 line symmetry of this scalene triangle. And what about equilateral triangle? Equilateral triangle has 3 line symmetry. 3 line symmetry. Okay, and circle, here is the area of circle equal by r power 2. This is the area of circle. Area of circle will be by r power 2, such that pi equal 22 over 7 equals 3.1 and 1400. Okay, square, the area of square equal side by side. Square, all sides equal lenses, then the area of square equal L product by itself, it will be L square. And the area of rectangle equal length times width. The area of rectangle is quadral. Each opposite sides are equal lengths and parallel. We call it rectangle. Okay, rectangle. And the measure of each angle is here equal 90 degree. And rectangles, then the area of rectangle equal length product by width. And rhombus, area of rhombus have product by diagonal 1 product by diagonal 2. We have diagonal 1 and diagonal 2. In the area of rhombus, it will be half product by diagonal 1 product by diagonal 2. Parallelogram. In parallelogram, we have two bases. We have the greater base and the smaller base. The greater base has smaller height and the smaller base has greater height. Then the area of parallelogram equal base product by corresponding height. The area of trapezium half sum of two bases product by height, half of sum of two bases, long base and smaller base, sum of them divided by 2 product by the height. It's the area of trapezium. Parallelogram and special case. Look at with me about parallelogram and its special case. Parallelogram quadrilateral in which each two opposite sides are parallel and equal lengths. We called it parallelogram. The parallelogram will be rhombus. Convert from parallelogram to rhombus if two adjacent sides are equal lengths. If two adjacent sides equal lengths, we called it rhombus. Or if two diagonals perpendicular, it will be rhombus because the two diagonals in parallelogram bisect each other. And if the two diagonals will be perpendicular, then we will have the rhombus. Then the rhombus is parallelogram which two adjacent sides are equal in lengths and two diagonals are perpendicular. Okay, it's the definition about rhombus. You can say rhombus quadrilateral which two adjacent sides are equal in lengths, or it's quadrilateral which two diagonals are perpendicular. And what about properties of parallelogram? Each two opposite sides are parallel. Each two opposite sides are equal lengths. Each two opposite angles are equal in measure, such that this parallelogram ABCD, the measure of angle A equal measure of angle C. Each two consecutive angles are supplementary, such as the measure of angle A plus measure of angle B equal 180 degree. Okay. Each two consecutive angles are supplementary. Supplementary, it means sum of two adjacent angles equal 180 degree. And diagonals bisect each other. Two diagonals bisect each other. Okay, and parallelogram will be rectangle where if any angles will be right, then parallelogram convert to rectangle. Then the parallelogram convert to be rectangle if each angle is right. Okay, if the measure of each angle equal 90 degree, then rhombus or parallelogram convert to rectangle. Then the parallelogram convert to rectangle if the measure of each angle equal 90 degree, or if two diagonals equal lengths, then parallelogram will be rectangle. Then rectangle is parallelogram which any angles is right, or parallelogram will be rectangle if two diagonals equal lengths. Then rectangle is a parallelogram which two diagonals are equal lengths, or rectangle is a parallelogram which any angles is right. Rectangle is a parallelogram with right angle, okay, or diagonals are perpendicular to be rhombus. Again, parallelogram will be rhombus if two diagonals perpendicular, and parallelogram will be rectangle if two diagonals are equal lengths, and parallelogram will be square if both sides are equal lengths and each measure of this angle equal 90 degree, or parallelogram will be square if two diagonals are perpendicular and equal lengths. Okay, then the square is parallelogram which two adjacent sides are equal lengths and the measure of each angle is equal 90 degree. We have two definitions of square: definition of rhombus and definition of rectangle. Okay, square is a rhombus which two adjacent sides are equal lengths and the measure of each angle equal 90 degree. Square is a rhombus which two diagonals are perpendicular, okay, and equal lengths. And rhombus is a parallelogram which two diagonals are perpendicular. Rectangle is a parallelogram which two diagonals are equal lengths. Okay, understood? So we can say square is a rhombus which measure of each angle equal 90 degree, and we can call square is a rectangle. Square is a rectangle which two adjacent sides equal lengths. If two adjacent sides equal lengths in rectangle here, then this figure will be square. Convert from rectangle to square with two adjacent sides equal lengths. Okay, and we can call square is a parallelogram which two diagonals are perpendicular and equal lengths. We have two definitions to get square. Okay, look at this definition here. First one, rectangle is parallelogram with right angle. First, rectangle is parallelogram with right angle. Rhombus is parallelogram with two equal adjacent sides. Rhombus is a parallelogram which two adjacent sides are equal lengths. Square is a rhombus with right angle. Square is a rhombus with right angle. All sides are equal lengths in what? In rhombus. All sides are equal in rhombus. Diagonals are equal in rectangle. Diagonals are perpendicular in rhombus. Diagonals are equal and perpendicular in square. Okay, you must pay attention about square and rhombus and rectangle. Diagonals are equal and perpendicular in square. Diagonals are perpendicular in rhombus. Diagonals are equal in rectangle. All sides are equal in rhombus. Don't write square, okay? If he asked you all sides are equal in what, write, choose here rhombus. Don't write square, because square all sides are equal in length and the measure of each angle equal 90 degree. We have two definitions. If you want to solve or write definition of square, you must write two properties of square: all sides equal lengths, or you can write all adjacent sides are equal lengths and the measure of each angle is equal 90 degree. And we can say the square is a rhombus which measure of each angle equal 90 degree. Square is a rectangle which two adjacent sides are equal lengths. And we can write square is a parallelogram which two diagonals are perpendicular and equal lengths. Okay, you must keep in your mind these properties. Next rule, talk about here figure square. The area of square equals side by side, or half diagonal square. We have the area equal side by side to the side square of, or we can write half diagonal square. It's area of square. To find the side here, you can get the side square root of area. To find the diagonal, you must try to product by the area and then get square root of the result. The perimeter of square equal 4 product by side. It's the perimeter of square. Parallelogram, area of parallelogram equal base times corresponding height. We have two bases. Longest base and corresponding height was smaller, and the smaller base and longest height is the corresponding. Then the area of parallelogram equal base times the height. To find the base, you must write area divided by height. Okay, you can find the parameter of parallelogram. Two adjacent sides product by 2, such that L1 and L2, L1 plus L2 product by 2, like parameter of rectangle, length plus width times 2. It's like it. Triangle, the area of triangle, half base times the height. Okay, we have base and height. Or if we have right angle triangle, the area will be half times base times corresponding height. The parameter of triangle equals sum of sides. To find the area of rhombus, you must write half product by diagonal 1 product by diagonal 2, because diagonal 1 not equal diagonal 2. Or you can write area equal base or sides product by height, side by height, because all sides are equal lengths and all heights equal lengths in rhombus. Okay, in rhombus all sides equal lengths, then all heights will be equality. Then you can write side by height to find the area of rhombus. Trapezium, the area of trapezium equal half sum of two bases product by corresponding height. Or you can write the area of trapezium, it will be middle base product by height. Middle base here, it's line segment joined between two sides in the middle. Okay, we called it middle base. Okay, product by the height. Area of rectangle equal length times width. To find length equal area divided by width. To find the parameter sum of length and width product by 2. The area of circle by r power 2, and circumference of circle, it will be 2 by r. What about reflection? Reflection about the point x and y. At x axis you must put x and change the sign of y. Okay, it's reflection. At x axis you must put x and change the sign of y, such that 3 and 2, if you want to find reflection at x axis, you must put x here and change the sign of y. Okay, it's a rule, you must rule in your mind. And if you want to find the reflection about y axis, you must put y and change the sign of x, it will be negative x and y. And to find the reflection about point x and y at original point, you must change the sign of x and sign of y. And what about rotation? Rotation point x and y at 90 degree. Rotation about 90 degree, you must replace them, replace y and x, and change the sign about the first. Here reflection 90 degree, rotate at original point by 90 degree. You must replace the places about x and y, first projection, second projection, replace them and change the sign about first. And what about rotate 90 degree around 0 by negative 90 degree? By negative 90 degree you must replace x and y and change the sign about second. Okay, again x and y, it's a point. To find the rotate this point around 0 by angles 90 degree and direction with the clock, negative, sign negative, it's meaning this direction with a clock because the sign negative. And if the direction 90 degree, the opposite of the clock, you must replace x and y and change the sign of first. And rotation 90 degree, it's equivalent negative 270. Okay, it's the rule to find rotation of 90 degree or negative to 270, it's equivalent. You must replace x and y and change the sign of the first about 90 degree or negative 270, and rotation negative 90 degree or 270 around 0, you must replace x and y and change the sign of the second, right? Y and negative x. And what about rotation around 0? Rotation around the point 0 by angle 180 degree, you must change the sign only of x and y, such that 3 and 2 you can find the rotation around 0 by angles 180 degree or negative, positive or negative 180 degree. You must change the two signs only. Okay, now we will talk about the angle. Acute angle and right angle and obtuse angle. And first we must know the definition of the angle. The angle is a union of two rays with same starting point. This angle ABC, we can call it ABC or CBA. Angle B or angle ABC, we can call it. Then the angle is the union of two rays with the same starting point. We have ray BC union the ray BA at the same point P. Types of angle: right angle, acute angle, zero angle. We have reflex angle, straight angle, obtuse angle. Okay, first, right angle, the measure of right angle equal 90 degree. Acute angle greater than 0, measure of acute angle greater than 0 and less than 90 degree. And zero angle, the measure of it equal 0 degree. Two ray was congruent. We have reflex angle greater than 180, less than 360. It's reflex angle greater than 180 and less than 360. We called it reflex angle, such that 190. We called it reflex angle. And straight angle, the measure of it equal 90 degree. Straight angle, the two ray in the same straight line. Okay, and the measure of this angle, it will be 180. We called it straight angle. And obtuse angle greater than 90 degree and less than 100 degree. We called it obtuse angle. An obtuse angle. Complementary angles. What about complementary and supplementary? Complementary angles, two angles are said to be complementary if their sum is 90 degree. We called it complementary angle, such that this straight line perpendicular to L1 perpendicular to L2 at the point M. Then the measure of angle M equal 90 degree. Then angle 1 and angle 2, the measure of angle 1 plus the measure of angle 2 equal 90 degree. We called it complementary angles. Okay, complementary angles. The two exterior sides are perpendicular. And what about supplementary angles? Supplementary angles, such as angle 1, angle 2. Sum of two angles 1 and 2 equal 180 degree. Two angles are said to be supplementary if their sum is 180 degree. Sum of them equal 180 degree. Vertically opposite angles. If two straight lines intersect, then the measure of each two vertically opposite angles are equal, such that angle 1 and angle 2. We have two straight lines cut at the point M, L1 and L2 cut each other at the point M. Then the measure of angle 1 equal measure of angle 2. We called it vertically opposite angles. Okay. And then cumulative angles at the point, the sum of them equals 360. The sum of the measure of the cumulative angles, we called it cumulative angles, such as this, we called it cumulative angles. Cumulative angles, sum of the measure of the cumulative angles at a point is 360. Then if we have angle 1 and angle 2 and angle 3, sum of angle 1 plus the measure of angle 2 plus the measure of angle 3 equal 360 degree. And two adjacent angles formed by straight line and ray are supplementary. We called it supplementary angles. The two exterior sides are in the same straight line. The two adjacent angles formed by straight line ray, we called it supplementary angle. Again, the two adjacent angles, such that angle 1 and angle 2, formed by straight line here, A, B, C, are supplementary angles. The two acute angles complete this example. He can ask you the acute angles complement what? Acute angle, because if we have 30 degree it's acute, the complement angles it will be 60 degree and 60 degree will be acute. Then the acute angle complement is acute angles. The acute angles complement is what? Acute angles, because the sum of them equal 90 degree, such that 30 plus 60 equal 90. The acute angle supplementary obtuse angle. The acute angle, such that, look at here, we have acute angle here 30 degree. We called it the acute angle. The acute angle supplement is what? Obtuse angle. The acute angle supplement is obtuse angle. The triangle theorem. The sum of measure of interior angles of triangle is 180 degree. Any triangle has at least two acute angles. Any triangle has at least two acute angles, such that right angle triangle we have two acute angle. Obtuse triangle and obtuse triangle. Obtuse angle triangle, here we have two acute angle. An acute angle triangle, we have three acute angles here, and here two acute angles, and here two acute angles. Then at least in any triangle, at least we have two acute angles. Okay. Number 3, if measure of angle B equal measure of angle A plus measure of angle Z, then this triangle will be right angle at B, because measure of angle B equivalent sum of measure of angle A and measure of angle C. Then we have right angle triangle at the point B, because the measure of angle B equivalent sum of measure of angle A plus measure of angle C. Question number 4. If measure of angle B greater than measure of angle A plus measure of angle C, then we called it obtuse angle triangle at B. Okay, if measure of angle B greater than measure of angle A, measure of angle C, then we have obtuse. And if we have equality, then we have right angle. And if we have measure of angle B less than sum of measure of angle A plus measure of angle C, we called it obtuse triangle. Okay. Number 6, measure of exterior angle of triangle equal sum of the non-adjacent interior angle. Okay, look at here about this triangle. We have exterior angle, sum of exterior, the measure of exterior angle equals sum of two interior angle without adjacent it, such that if we have angle 1 and 2, then we have here angle 3, then angle 3 equals sum of angle 1 and angle 2. We called it exterior angles. Measure of exterior angles of equilateral triangle, it will be 120 degree. We have equilateral triangle, then the measure of exterior angle of equilateral triangle, it will be 100.